Oracle eBusiness Suite architecture. In this presentation, we will go over Oracle eBusiness Suite architecture evolution, then the layout of Oracle eBusiness Suite architecture, the application technology layer and how it fits within an Oracle EBS, the Oracle apps file structure for the eBusiness Suite, and the data model. Oracle EBS architecture. Again, here whenever we say EBS, it references Oracle eBusiness Suite, which encompasses all Oracle applications related to enterprise resource planning, primarily the financials, manufacturing, and anything associated in that space. So initially, when Oracle came out with their initial versions of Oracle applications, it was a character-based application, and it was basically a character-based mainframe applications back in the late 1980s and early 90s. Whenever the clients used Oracle applications, the applications itself used to run on a mainframe application, and the clients would access their application using a dumb terminal connected over the network. So whenever somebody has to access Oracle application or create an invoice or entering a vendor, they would log into their dumb terminal or they would log into their terminal, and once they access the application, they would enter the information into the application. Now with the mainframes or with the mainframe application, when let's say when the user is entering a vendor or they're creating a vendor, so when the user enters the vendor information, after they enter all the information, and when they hit submit, or when it goes to the next field, so the end user is entering a vendor name and then vendor number. Let's say the vendor number has to be all numbers only and no characters or no alphabets. So when somebody enters that vendor number information and hits tab to go to the next field, let's say address, it would make a round trip to the mainframe and to validate if the user entered all numbers, and if they entered any alphabets, it would make the round trip come back, and it would not let them go past that field until they change it or until they adhere to that entry form. And similarly, when they go to the address, and let's say in the zip code, if they put any alphanumeric characters for a US address, it would not let them go past the zip code to the next field until they fix the address. And every time for each field, the application makes a round trip to the mainframe to validate the entry. Now if we take that and extend that across the organization, and at any point in time, let's say there are more than 2 people trying to access the application and making the entries, you see the network traffic kind of increases tremendously, and that kind of puts a lot of performance on the network, and as well as on the application on the mainframe as well. And this resulted in the performance issues, and at that point came the next set of architecture during the early 90s and the mid 90s. That was the client-server architecture. In the client-server architecture, the main idea is the bulk of the business logic, which does not require inserting information into the database, or which does not require interaction with the database, that particular logic would be run on the application on the client. And so, for example, in this case, when somebody is entering a vendor and they're going through the vendor screen, and at the time, let's say they enter the vendor number and then tab over, instead of making the round trip to the server, the business logic or the application logic that is residing on the client itself using the client resources would validate if it is a all numeric or not, or if it adheres to that validation rule or not. And depending on that, it would validate, and if the entry is validated, it would let the user navigate to the next field, and so on and so forth. So in this case, by using the by implementing the business logic and running that business logic on the client, you're reducing the network traffic, and is also you're reducing the use of the server, because let's say if there are 4 different end users who are accessing the application, when the input is being validated, the 4 users, they are actually using the processing power of the individual PC, right? So there is no load on the server, and the only time the data is the application is accessing the database server is at the time of inserting the information, or at the time of retrieving an existing information. But the other business logic or business validations are happening on the client using the client the PC processing power. Now, this is great in terms of performance, but as we all know, any software that is created is not free of bugs. Anytime you have a piece of software, what do you have? You have bugs, which would mean that from time to time, the software vendor would be releasing patches to address those bugs, right? Or they would release a mini version to add a new functionality that the clients are looking for. So whenever the software vendor releases a patch or a mini release for a version of the Oracle applications that are running, the organization would have to go and apply these patches and update their software so that if they can make use of that new functionality, or fix the bugs that they are experiencing. Now, what would that mean? So if an organization which has 4 end users using 4 different desktops, that would mean they would have to, the maintenance people would have to go to each of these desktops and update each of these desktops individually, right? Now, if we take that one step further, and let's say if an organization has 100 employees who are accessing or using the application, what would that mean? That would mean that the maintenance folks would have to plan for the upgrade event, and probably plan for a long weekend or something of that sort, so that they can update all those 100 desktops at once. So with the client server, it kind of brings up new set of challenges, which would be the maintenance and upgrade challenges, right? So that kind of led to the next version of the architecture, which was the 3-tier architecture, or the 3-tier logical architecture, which we will cover in the next segment of the video.